What is the enthalpy change for the reaction in kilojoule per mole? Carbon dioxide gaseous plus hydrogen gaseous forms carbon monoxide gaseous plus water as a gas. So we have been given three equations. Let's label these equations as a 1, 2, and 3. So we need to add these three equations to have the overall equation. So we can see in first equation we have carbon dioxide. The carbon dioxide is on the product side, but we want carbon dioxide to be on the reactant side. So we need to flip that equation. When we flip that equation, so delta H for first equation will becomes plus 566. But we have 2 moles of carbon dioxide, but we need 1 mole of carbon dioxide, so I will divide that with 2. So we will have 2, 8, and 3. So plus 283 kilojoule per mole. Okay. Second equation has hydrogen. We want hydrogen to be on the reactant side. So we have 2 moles in equation 2, but we need 1 mole. So we can divide equation 2 with 2 as well, and we will have minus 572 divided by 2 will give me 2 times 4, 8, 6. So minus 286 kilojoule per mole. Okay. So we want a water H2O gaseous on the product side. We have on the reactant side in equation 3. So we need to flip that equation. When we flip that equation, so delta H will becomes plus. So plus 44 kilojoule per mole. So let's add 283 and 44, 7, 12, and 327. Take away 286, 1. So that will give me plus 41 kilojoule per mole, and the correct answer is D. Which is a renewable energy source? Natural gas, option A. No. Is finite. Uranium, no. Finite. Coal, no. Finite. So that leaves us wood as the option. Yes, wood is a renewable energy source. Simple, straightforward, easy question. Which are endothermic processes in a Born-Haber cycle for the formation of ionic compounds? Enthalpy of atomization is endothermic process. Energy required to form 1 mole of gaseous atom from an element is in standard state. First electron affinity is exothermic. Energy is released when 1 mole of electron they added to a gaseous atom. And third one, first ionization energy. Ionization energy is always endothermic process. Energy required to remove 1 mole of electron from gaseous atom. So one is endo, and third one is endo. So we're looking for option 1 and 3. So which is B? So B is the correct answer. What is correct as system approaches equilibrium? A. Q remains constant. No, that is not right. B. Kc increases. No, equilibrium can be attained from either direction. Either product they can go back into reactant, or reactant they can go to product. C. Delta G becomes more negative. No, delta G approaches 0. Yes. So as a system approaches equilibrium, delta G approaches to 0. So D is the correct answer. The complete combustion of 20 centimeter cube gaseous hydrocarbon CXHY produce 80 centimeter cube of gaseous products. This volume reduces to 40 centimeter cube when water vapor is present, condenses. All volumes are measured at the same temperature and pressure. What is the molecular formula? So let's write down the general equation for combustion of hydrocarbons. So CXHY plus O2 will produce X CO2 plus Y over 2 H2O. Oxygen will be X plus Y over 4. So we started with 20 centimeter cube of CXHY, and the volume of carbon dioxide produced is 40 centimeter cube, and the volume of water produced is 40 centimeter cube as well. So if we start with 20 centimeter cube of hydrocarbon and the volume of carbon dioxide produced is 40, so the ratio is 1 into 2. So 1 into 2, so that suggests me there are 2 carbon atoms in given hydrocarbon. So that means A and D is not the correct answer. So that leaves us between B and C. So let's work out the number of hydrogen in the hydrocarbon. So for every 1 volume of CXHY, so the volume of water produced is Y over 2. So we can say volume of H2O will be equal to Y over 2 times by volume of CXHY. So the volume of water produced is 40 is equal to Y over 2 times by the volume of hydrocarbon is 20. So if I solve for Y, we will have 4. So as the number of hydrogen given is 4, so C is the correct answer. Bit challenging question. If you remember that formula, you can answer this question. The diagram shows energy profile of a reaction. So we can see this is an endothermic reaction. Reactant, they have less energy as compared to product. So which combination is correct? Activation energy for the forward reaction. So activation energy is minimum energy required to start a chemical reaction to push reactant all the way up to transition state. So the activation energy is from here to here. So that will be Y minus X. So let's narrow down the choices. So A, no, B, yes, C, no. So that leaves us between B and D. So let's move to the next part of the question. So the activation energy of a reverse reaction. So to make things a lot easier, I will draw another energy profile diagram for exothermic reaction. So the product there becomes reactant and the reactant there becomes product. And okay, so reactant for reverse reaction and this is product for reverse reaction. So now this is Z and this is X and this is Y. So activation energy required to start a chemical reaction to pushing reactant all the way up to transition state. So this is the activation energy. So that will be Y minus Z. So the activation energy will be for reverse reaction will be Y minus Z, hence B is the correct answer. What is the main reason for the increase in rate of reaction when temperature is raised? So at higher temperature, the average kinetic energy of the particle is higher. There are fewer particles which have low energy and the more particles have higher kinetic energy. So what does it mean? According to Maxwell-Boltzmann distribution, so the more particle will have energy equal to or greater than the activation energy. So hence a greater proportion of collisions are successful and A is the correct answer. What is the equilibrium constant expression for the following reaction? So K should be equal to molar concentration of product, so in this case SO2 to the power of the coefficient times by molar concentration of O2, and the coefficient is 1, divided by the molar concentration of reactant, so 3 to the power of their coefficient, which is 2. So let's go through the options. So A is the correct answer. Which statement is correct about points X and Y on an energy profile diagram? So this is an example of exothermic reaction and where we have true transition state. Transition state is the highest energy state in energy profile diagram. So X and Y both, they are transition state, and we have one intermediate somewhere here. So let's look for the options. So X is a transition state and Y is an intermediate. No, is wrong. Y is transition state as well. B, X is an intermediate and Y a transition state. No, X is transition state as well. Option C, X and Y are transition states. Yes, so C is the correct answer. The equation for the reaction between two gases A and B is shown below. When the reaction is at equilibrium at 600 Kelvin, the concentration of A, B, and C are 2, 1, and 2 mole per gm cube respectively. What is the value of equilibrium constant at 600 Kelvin? So let's write down the K expression. So equilibrium constant will be equal to molar concentration of product raised to the power of the coefficient divided by the molar concentration of reactant times by B square. So we have been given the equilibrium concentration. So let me substitute these values. So the value of C is 2 square divided by the value of A is 2 times by the value of B is 1 mole per gm cube, 1 square. So 4 divided by 2. So the answer will be 2. So the value of equilibrium constant will be 2. So correct answer is C.